Good morning or good evening according to your time zone. We all know what it's like to have a word in tip of our tongue and we just cannot get it out. Now imagine having that feeling every time you are trying to say something for the rest of your life. That's aphasia. Aphasia is the loss of language from stroke or brain injury. We all know that communication is at the core of our relationships, so imagine someone suddenly lost his ability to understand speech, to talk, to read, and to write, but he hadn't lost his intelligence. Imagine how everyday tasks would suddenly become difficult. 15 million people suffer from stroke worldwide each year, and over 30% of stroke survivors have this condition, which means millions of people have aphasia worldwide. Moreover, it's hard for speech therapists to cover all this increase of patients due to their lack in numbers and the long repetitive sessions, which make it expensive, boring, and embarrassing as well. So for now, current traditional rehabilitation still depends on showing the patient some photos of objects on a paper or iPad and pronounce their names with accurate lip articulation to mimic it. During our investigation of the market, we found some applications like constant therapy and tactile therapy, which make a good use of the online follow-up for speech therapy and give feedback for both patients and doctors. And for comprehension training, there is Limosity, for example, which based on gamification. Eva Bark is also found in the heat of virtual reality gamification and interaction, but in fantasy way. Other majority of the applications are communication tools called AAC, in which patients just press on icons to say what they need. However, there is a significant lack in all these technologies in Arabic language, especially for rehabilitation purposes. For us, it's about the human connection and being spontaneous. So our objective mainly is to help the speech rehabilitation process for a more natural life and reinforce home practice and training with covering large number of patients in need.
Therefore, we made our contact with therapist and speech center to test the concept understanding and needs, and we found a great concept. Also, we made a survey as well on public to get some statistics for best recommendation to our system to make it more fun and attractive, especially for repetitive action. The result showed that the majority prefer virtual reality as an amusing way. They also prefer home treatment and follow-up. So, considering the survey result and the therapist experience who said the home practice is the most effective way for fast recovery, and with studies proved VR as an effective treatment for aphasia. We, we started to design our system to help the therapist and the patient. The therapist can make rehabilitation plan for his patient to do more sessions at home, then get an accurate feedback report for him. Our system includes a VR game in Arabic, like a true session, that work on understanding, listening, and speaking, but with some fun too. During the session, we take a voice and process it in the cloud using AI algorithms, then give real-time feedback while playing, and make a report for the therapist. Every session, the therapist using our website to put a session plan and see progress of patient and make decisions depending on it. Our project is a special made for our country and society. It is the first speech rehabilitation app for aphasia in Arabic, and we made it more fun by inventing virtual reality games that allow patients to speak, easily interact, and get more immersed in real life by playing VR. Also, we get an accurate feedback by using AI systems. Our project contains the most important feature and advantage of all current mentioned solutions, which are merged together in the most effective way, considering lip motion for an effective learning process, feedback system, virtual reality immersion, and focusing on the Arabic language in local accent, all in one system. that allow therapists to follow up and interact with patients.
Now I'm going to talk in detail about the game implementation. As mentioned before, in this part of the system we seek to improve patients' ability of both language pronunciation and comprehension. Unity 3D is our main development platform. This is the opening main menu from which patient can choose which scene to enter and which category of words to train on. In next milestones, we are going to customize the layout and reduce the number of buttons and clicks as the therapist recommended. The first part in the game is the pronunciation training part, in which we simulate the real rehabilitation session. The most significant part here is a very accurate lip movement of the avatar, or our virtual therapist. After searching, we found out that this 3D Studio is what we need to fulfill this requirement, so we used it and create the avatar and mimic the lip motion of the target words we previously chose. But unfortunately, Arabic wasn't one of the embedded languages in this 3D Studio, so we use the manual mode to mimic the lip motion. After that, we can import the character with its animation in the scene assets in Unity. The second part here is the virtual city. We've created a number of realistic scenes to make the patient feel as if he's in the real world: living room, kitchen, and the street. This part focuses mainly on measuring the patient improvement by developing some practicing tasks. And based on his answers, we could measure the level of mistake in his pronunciation or understanding abilities by sending this data for processing and getting a feedback. For now, we are in the process of creating the tasks and the on-screen feedback. As we mentioned before, the cumulative feedback that's being sent to the doctor is one of our main concerns. We started in developing the front end of the website using Angular and Bootstrap. It mainly consists of three parts: the home page, registration page that manages the doctor to access his patients list, and enter the most important part, the third one, which is a dashboard, in which the doctor can view the feedback and assign tasks for patients if needed. But for now, the dashboard layout hasn't finished yet.
According to the AI algorithm part in the game, in this part we are building a speech recognition model that recognizes specific words, which were selected by us using neural networks. Firstly, we started with English datasets because of the lack of Arabic data. We used Google's Speech Commons dataset, which is a set of 1-second audio files, and each one containing a single spoken English word. These words are from a small set of commons and are spoken by a variety of different speakers. The dataset is already optimized and pre-processed. After that, instead of using directly the sound file as an amplitude versus time signal, we use the spectrogram of these audios to be as input to the neural network model. Finally, as we know that convolutional neural network works better in detecting local features patterns in different parts of the image, and are also good at capturing features which become subsequently complex with every layer, so we implemented our model using CNN in Python. And the accuracy of the test data was around 95%. Now we are working on implementing the CNN model on Arabic data. According to the data acquisition step, we have already started with collecting data of frequent speech of different major categories in Arabic language. We collected about 5,200 records of 10 short Arabic words by participants of both genders, male and female, with ages greater than 18, and the mother tongue of all participants is Arabic. The second step was pre-processing, to prepare our data to be ready to use. Firstly, we started to remove white background noise, but we still have issues in subtracting the colored background noise from the audios. Then, we implemented a silence detection technique to detect silence in records, and then remove it. Consequently, to make all audios have 1 second in length, we used zero padding at the end of audios, which were less than 1 second. Finally, the pre-processing step have already been finished. After that, we extracted the spectrogram of the audios, and the problem now became image classification. And now we are still working on integrating the CNN model with the available collected data.
From the start of this project until now, we are working according to specific steps in our plan. The first step was getting an idea and collecting all data about the problem and market needs. The second step was searching for the most suitable tools for our project. The third step was development, so we started to divide the system parts among us to work on it in parallel, to utilize each team member capabilities and skills, and we are still working on this step. The next step will be the integration of the whole system to a cloud server and the website. The last step will be evaluating the system performance and getting validation from doctors and finalizing the project as a graduation project. But we are looking forward to make it a product as soon as possible. So, does it really worth all this work? Does the market in dire need for this product? When we talked to doctors, the first thing that they said was that speech therapy doesn't have a great attention, especially for adults in our society. And it looks the technology, and according to statistics, it is no longer a rare disease, and its fast spreading has become more dangerous as we think, and it puts a pressure on the therapy centers and doctors. But with our approach, we believe that we can move from this to this, and speech therapy can be everywhere to relieve this pressure, allowing doctors to cover all these patients. It also provides the patients with a flexible, convenient, and efficient home therapy in their own language and in interactive way, and they have a real-time feedback to know their progress. So again, we are Speech Media. We are trying to build a platform for doctors and patients to make it easier to have a speech therapy process. And thank you.